Or maybe the nesting, right? Which nesting means that we're equally placing components at an equal distance from one another, so that way the robot can pick. And if they're all 1 inch apart from one another, the robot program can also just be 1 inch apart from one another and be able to perform that pick operation. So somebody has to mechanically design that nest for all the things to be equally separated from one another. Then there's a small calculation to how many things can we fit on a nest versus what's the robot's reach. So there has to be analysis on the robot reach. And so I'm just giving like a bunch of brief examples of some things you'd have to learn in these different skill sets. Now let's go ahead and switch over to the robot programming thing and show you kind of how some of these things align. Going back to the nest part of it, and the mechanical engineer has to design that nest with the components, let's say 1 inch apart or 25 millimeters apart if you're working in metric. Let's say for instance they're 25 millimeters apart, and in the robot program, you have to adjust that. And a good thing we're talking millimeters because all robots are in millimeters. So the robot program needs to auto adjust. You don't teach, if there's 50 pieces on this nest, you don't teach 50 pickup positions. That's not the proper way to do the programming. The proper way to do the programming is that you teach one position and then you add 25 to each one. Then after you go, let's say they're 10 wide, you add a 10 to the other direction, or when I say you add a 10, you add up to 10, then you need to multiply by 25, let's say they're an inch up as well, multiply by 25 millimeters, or you need to add 25 millimeters, but it's a multiple if you're multiplying by the number of rows. See, like this is the mindset, we'll leave this in the video, right? This is the mindset of how you have to think as a programmer to be able to accommodate picking from a nest and programming in a way that's the proper way of programming.